Hello and welcome to today's video. Today, as always, of course, we have a very important topic to talk about. You see, our duty, our job as software engineers, as programmers, is, well, not to play around with tools, not to fiddle around with frameworks and CLI commands and so on. It's to build useful software that helps us, that improves our lives, someone else's, that brings some value to the world. And I think any technology that helps us achieve that easier, that makes our job easier, that helps us focus on what's important, on providing the actual value and not wasting time installing all weird software and trying to set it up, well, that technology is important and we should be discussing about it. And of course, one of those is the so-called containers. Containers really took a lot of attention recently, in the recent 10 years maybe or so, and for good reasons. I just mentioned a few. So let's see. Today we are going to talk about containers, and we're going to start describing them. So what they are. Then we have to. Well, containers are more abstract. They are not like a specific thing. They are more of an abstraction layer or an so it's similar to ECMAScript and JavaScript, meaning that ECMAScript is just a standard specification, while the JavaScript is the actual implementation of that standard, of that specification. So in our case, we are going to talk about Docker, of course, as you might have guessed, how it works, and how we can use it, of course. Then we are going to see how a tool, Docker Compose, which is built on top of Docker, can help us run multiple containers, multiple different containers, and manage the connection between them. It also makes makes working with Docker much easier. I'd say it's more expressive. We no longer actually need the CLI that much. We just define a file saying what we want, and maybe we need 2 or 3 commands after that to use that file. So yeah, we're going to talk about Docker Compose. Yes. And that should be it. Yeah, of course, here in Docker we actually will talk a bit about the architecture, actually how it works. Then we're gonna talk about how it works on various operating systems. You see, I have Windows. Maybe you have Mac OS or Linux. How it works with different OSs. Okay. Then what? Well, maybe then we can play with it a bit. Run some containers. Then we're going to talk about the Dockerfile, which actually helps us to build our own container. And yeah, maybe let's just call it building our own container, in which we basically run an application. Okay, and then with Docker Compose, so we are gonna see some issues when we build our own container. We are gonna containerize an application that works with a database, and of course the application needs a database. So we either can install also the database, so Postgres in this case, in that container, or we can run it in a separate container and just make the connection between the two. and that's where Docker Compose steps in. So we are gonna define so Docker Compose works with the so-called Docker Compose.yaml. So it's a YAML file describing the containers that we want and how they talk to each other, more or less. So we're gonna talk about Docker Compose.yaml and then some commands, maybe running multiple containers, let's say, and we are gonna encounter an issue which brings us back to Docker actually, and it's we will see. Let's call it bonus issue. So yeah, that should be all. So let's start. So as we discussed, containers are basically a way or a technology that allows us to run various tools, various applications, various systems in an isolated system that have their dependencies already baked in and that can be run on any hardware or any operating system that has the container engine that it needs to run. Basically that's the whole promise. So we can use it to run things like databases or other tools. Maybe we need a Hadoop cluster, we can totally do that. Maybe we need Redis or memcached for caching, also a good use of containers. Or maybe we want it for local development, because maybe we want to keep our local machine clean, so we don't want to install Java and Node and Python and all that. We just want one container engine, and when we are done with the project, we get rid of all the dependencies that are inside containers actually. And of course, it helps us with the so-called dev-prod parity, meaning that the environments in which we develop our application and run it during the development should be as close as possible, so as similar as possible to the environment in which we run the application, so to the productive environment. And containers definitely help us there, because they basically create the same environment. Of course, it's still up to us to connect the right services to that container, but the environment in which the application is actually running, so the Java version or the Node version, is the same, and it's built in exactly the same way. So it brings a lot of benefits also on that side. And of course, the main container technology or the main container engine is Docker, as I'm sure you already know. So they have this really nice documentation website. They describe pretty much everything they do. So you see there are four important entities, let's say. So the first one being image. If you think about object programming, for example, image would be a class. So it's a template describing how things should be executed. Then we have containers. Containers are objects of a class, so running images basically. Then we also have networks and volumes. We are gonna actually see and use those today. Okay, what else is important from here? They also describe the underlying technology, and it's useful to know about it. They use namespaces and control groups and union file systems. Now, all these three technologies are part of the Linux kernel, meaning that, well, Docker needs Linux to run, which is interesting because I don't have Linux. Maybe you also don't. Chances are you don't. So yeah, how do we run Docker then? We're gonna see that. But maybe let's talk a bit about namespaces. So namespaces are, as I said, part of the Linux kernel, and they help us create isolated environments, isolated workspaces, in which we can run the so-called container. Now, these namespaces actually give the process the impression that it has the entire system at its disposal, and that's exactly that's intended, because we want our application to think that it has all the resources available. Then we have control groups, or C groups, as you might have seen them, and it's a feature of the Linux kernel which allows us to impose certain resource limits. So they allow us to configure exactly what resources a container has. Maybe we wanted to have a certain amount of memory, or a certain CPU, and so on. And last but not least, union file system, or union FS. Well, it's what enables Docker to not take too much space. Because you see, compared to a VM, an application that's running in a container pretty much thinks is running in a VM. It's not much difference from its perspective. However, there are quite a few differences, and one of them is the file system. So when we boot up a container, a Docker container, that container will have the entire file system of Linux. So it has directories as /root, /home, and so on. All the directories that you see in a normal Linux distribution. However, they are not specific to that container until the application that's running in that container does something to those files. So as soon as it writes to one of those files or creates a file, then it gets its own version of that file. So basically, Union FS, it's a way to have a copy and write file system, and of course it tremendously helps us to reduce the size that containers take, because basically we only have to maintain files that were modified by that container. Okay, then we want to before we continue, so Docker is like the de facto way to run containers, but of course there are other engines. Of course there are multiple technologies. For example, there is also Rocket, which unfortunately is deprecated, so they are no longer supporting it. We can of course check out the Kubernetes supported runtimes, and they list here containerd, CRI-O, and Docker, of course. By the way, Kubernetes is just a container orchestrator, so it's a tool or a platform that manages containers for us. So it manages their life cycle, it creates them, it scales them, so adds multiple containers. It handles the communication between them, it exposes them to the world, and so on. Maybe we will talk about Kubernetes in a separate video, of course, and I'm sure you already know about it. Yeah, so that was about other container tools or engines. Now, regarding actually running Docker, how do we do that on Windows or macOS? Well, as we saw, Docker needs Linux. It doesn't work without it. And of course, on Windows and Mac, we can install Docker as a program. And what that does, basically, more or less, it creates a Linux virtual machine in which Docker is actually running. And the program that we install just handles or makes the management of that VM easier for us. And also it exposes the CLI and so on. By the way, they have this nice blog. So the Docker team wrote this nice blog about running Docker on Windows subsystem for Linux. By the way, Windows subsystem for Linux is part of Windows 10, and it's a way to run Linux as part of Windows 10. And with later releases, so I think 1903, they added WSL2. So it's an improved version of the first engine. And here they describe how they are using it to run Docker on Windows. Basically creating the Linux virtual machine they need and how they expose it to us. What's interesting from here, well, the entire article is interesting. For example, when you install Docker, you can use the WSL tool to list the distributions that you have. So you can install multiple distributions, Ubuntu, of course, and others. And that's the command to list the installed distributions. I didn't install any, but if I press that, if I run that, we see I have two distributions, Docker Desktop Data and Docker Desktop. Well, those are the VMs used by Docker to run Docker. They explain here what each of those two does and why there are two. Let's see if we manage to find those. Yeah, so if we take a look at this, so Docker Desktop, we have, they call it the bootstrapping distro. So if you take a look at this image, it's this larger block. So this is where all the matching happens. And then Docker Desktop Data, also here, Docker Desktop Data is where they store some data, as you might have guessed. So there it is. When they initially announced that they will support WSL2 instead of Hyper-V, so on Windows Docker, until this version of Windows, the Docker used Hyper-V. So that's the hypervisor that comes with Windows 10. Actually also 8.1. And well, while it's great, so it helps us get the job done, the issue with it is that it's a tier 1 hypervisor, meaning that it runs actually not on Windows, but on the hardware itself. That's why you have to restart the computer when you enable or disable Hyper-V. So it's a much more powerful hypervisor, but unfortunately it doesn't allow us to use tier 2 hypervisors. So you cannot run tier 1 hypervisor, which runs directly on the hardware, and then a tier 2 hypervisor, which runs on a host operating system. So for example, we cannot use Virtualbox if we have Hyper-V installed. Of course, they added a way to run Virtualbox, so the Oracle added that in later versions, I think around version 6 or so, but the performance is not great. And I was happy when they said that, okay, we will work with WSL2, no longer need Hyper-V, and I was, okay, finally I can use Docker and Virtualbox. Well, unfortunately not, because WSL2 itself needs Hyper-V. It uses certain tools or certain components of it to run the actual Linux system. So yeah, we are still dependent on Hyper-V. But well, that's fine. By the way, if you want to work with virtual machines, then I can also recommend Vagrant. So Vagrant is more or less a CLI which helps us manage virtual machines. Yeah, it's very simple. It's very easy to use, very fast, and it also works with multiple providers. So Virtualbox, Hyper-V, how was that called? VMware, of course, and others. Even works with Docker actually. Yeah, that was a side note. Also, hopefully, I hope this was helpful to get some understanding of how Docker runs on other operating systems. On macOS, it's a pretty similar approach to Windows. Of course, it doesn't use WSL2 and Hyper-V. Then let's use Docker a bit. So Docker, when we install Docker, we get the Docker command, of course. And the first thing they say to do is docker run hello world. And if we do that, well, guess what? We just run a container which printed this message. That's all it did. And they also say if you want something more, maybe try that one. We're not gonna try it. So we saw the first command, docker run, or run. Now, what's interesting about that is that actually it's just a wrapper on top of two commands. So we have docker create hello world, and then docker start, and now we have to copy that. By the way, containers have this really long ID. We can just take the first few characters, and if there's no collision with other containers, most likely there won't be unless we take just the first character. So then that should be fine. I mean, even like that should be fine. So docker start, yeah. Docker ps, we don't have it. Okay. Anyway, docker run is just a wrapper for those two commands. Now, let's clear that, and let's actually use Docker for what it's supposed to be used. So we have this demo application, as you can see, we're in this folder, demo app node. Basically, it's a node application, which it's an API which retrieves, or that we can fetch some codes from. And well, I already have code, VS Code opened with it. That's the app. So some files here, some index. That's the main one. Now it needs a database to run, and let's run it without the database at first. So let's comment out everything related to the database. Also here, when we retrieve that, maybe we comment that out and we say return. So let's return the same code always. So we're gonna say text do what you can with what you have where you are. I think that was the quote, more or less, and the author was Theodore Roosevelt. Okay, so we have that. Let's also comment that out. Now if we run the application, we are not using Docker yet. Maybe let's use this one. So node src index.js. So yeah, we have the application running. If we go here, we have the code. Cool. Now let's say that we don't have Node installed on our machine, or that we are deploying, or we want to deploy this application on a server and we don't want to bother installing Node on that server. We just want to run the application. So that means we have to containerize or dockerize the application. So we are going to start that, or in order to achieve that, we basically have to build the image. remember, images, containers, networks, volumes, and so on. So we want to build the image, which tells Docker how to run our application, more or less. And for that we use the so-called Dockerfile. And well, to do that we basically create a Dockerfile. That's exactly the name of the file, Dockerfile. By the way, if you work with VS Code, probably other editors, you can install extensions, and of course I have an extension for Docker installed, which adds certain features which we will use. So the Docker file. Now this has multiple keywords, let's say, and the first one would be from. See, the extension I was talking about already suggests something. So we have the from keyword, and basically that says which is the starting image, so what we start with. And remember, we have a node application, so it would be great if we could start with an image that already has node installed. And of course we can just write node. I think we even have autocomplete. Yeah, we have autocomplete for image names. By the way, the image comes from the Docker registry. If we go to it, Docker registry, not to the documentation. Where is it? Docker Hub, maybe. Let's see. If we search for node, guess what? Here it is. It's probably like in top 10 containers or images. They also tell us how to use that image, how to import it. Yeah, so Docker pull will already happen when we do this from node. Also looking at the tags, so you see many tags here. Well, if we leave it like that, it means this. That's the equivalent. So if nothing means latest, always means latest. So latest is just a tag. If we search for it, you see latest. Or we can go for Alpine. Now Alpine is a very common word you see in Docker, and it's basically a version of Linux that's stripped down of basically everything that's unnecessary. So we have a distribution of Linux that only runs containers, more or less. So we are gonna use that. Then we might want to set the work directory, meaning where the application will be running. So let's set that in the srv -app. Remember, we have the complete Linux file system available to us. Before that, maybe let's create that folder, because it doesn't exist. So the srv folder exists, or directory does exist, but the app doesn't. And for that we use run. So that's a way to run commands. And it also creates an image, a temp or an intermediary image from this. So we start with this image, then we run our command, which creates another image. So our command just creates the directory srv app. Okay, we set it as the working directory. Then then we want to, we could just copy the files, install the dependencies, node modules, and run the application, but that's not ideal, because as soon as we have maybe a small change in our code, we would have to again copy everything, install all the dependencies again, and well, that's unnecessary work. But instead we could just copy package.json, so this file where we have the dependencies listed, to srv app. Yeah, so basically copy there. Then we could run npm install. So that would install our dependencies listed in that. And last but not least, we can copy everything. So everything into srv/app. Okay. Also, a common practice is to expose or to define the port that the application uses. It doesn't really do anything. It's just for well, information purposes. We're gonna see how to actually expose a port when we run the container, and of course we have to use the cmd. So that well, it's pretty similar to run, but it will not build a separate image. It just tells Docker what to execute when the container starts. So in our case, we want to run node node and then src index.js. So basically we want to run our application. And if everything is fine, then we should be able to build our image. So meaning docker build dot. So in this file, or in other words, hey Docker, look for the Dockerfile in the current directory. So if we do that, Docker should pick up the Dockerfile, see what they have to do. Import the node Alpine, build intermediary images. You see the IDs here, so those are intermediary images. And once it installs the dependencies, let's give it a second. By the way, there is no way for us to use those intermediary images or containers because they are gone, so they are just temporary. We're gonna be left with the last image. You see, you remember, maybe you noticed that it took some time. So it even says here, okay, I copied everything into the Docker daemon. Maybe if we stop that. So yeah, let's clear that. So you see, we have the node modules here. Now those shouldn't be really copied into the Docker container because, well, we have Windows, there is Linux, maybe we have some native dependencies which need different packages to run, and for that we can use the dockerignore file, in which we can specify Docker modules. Okay, now if we run docker build again, maybe before that let's image prune. So that's gonna remove all the images which are no longer needed. Let's do that. Yes. Yeah, so it removed some images. Now if we try the build again, by the way, we can do one more thing. We can tag it. Remember, in case of node, so they have the tags. Maybe we can call it. So we use the -t parameter, and we can call it, well, latest is the implicit tag. Maybe we can call it YouTube. Why not? Okay, you see now sending build context to Docker daemon was much faster, so just a few kilobytes as previous, and compared to previously when it copied or sent several megabytes. And it's already done. So it created the image. Right. So when I said that, well, actually what it did was this. So you see it created YouTube latest. So if we wanted a certain tag, maybe what date is today? 02, so maybe November, or I don't know, other tags which would make sense, well, we could specify them like that. Now we have our image built. You see we got the ID here. We can use either the ID or the name from here. So let's try with both. So docker run, and it's listening on port 3000. And if we go into the browser and refresh the app, well, we don't have it, because remember, we have to expose the port. Even though we listed the port here, it doesn't do anything actually. So if we close the app, not the app, the container, docker run, and now if we specify the port, so -p, we want to expose port 3000 on port 3000. So the container port 3000 should be mapped to host port 3000. Maybe we tell it YouTube now, and it started. By the way, when you specify the name here, it's gonna initially look locally for that image, and if it doesn't find it, it will look into the in the Docker Hub for it. But since we just built that image, it found it and run it. So now if we refresh the page, we get our code. Now, which of those is actually the host port? To be fair, I always forget. Maybe let's try with a different host, different port here, and see what happens. Okay. Well, I guess it's the first one. So that's the host port. Yeah, and now if we open this on port 4000, we should again see the application. Yeah, and if we issue docker ps, we should see multiple containers. So they are still running. So maybe let's stop them. So let's pick them one by one. I think we can also stop multiple containers. Let's see if we manage to do that. Okay, so docker stop that and that. And if we give it a second, you see also Docker gives them random names. Yeah, I think we could have stopped also a container by issue the command with like this, and then copy the name from here. But since they are already stopped, okay, let's then prune the containers. So get rid of them. Container prune. Yes. Okay, so we got rid of the container, we containerized our application, but if you remember, well, we had our application actually needs a database, because right now it just returns the same code, so it's not that interesting, let's say. So we somehow have to give it access to a Postgres database. That's what it uses. And of course we can install Postgres in the container. So we could extend the Dockerfile, or maybe start from a Postgres image. But a more elegant way, of course, is to have a separate container with Postgres running, and then allow the connection between the two. And that's much easier to scale, to manage, and if one of them crashes, well, it doesn't affect the other, and so I mean, it does if the database crashes. Of course, the application might have some issues. Okay. Now, if we go back to our application and comment everything that we commented out, of course, if we run now the application, it's not gonna work. So src index.js, it's gonna say something, okay, the database doesn't work. Yeah. And if we go back to our initial to-do list, so we started here, we discussed about that. Okay, then we also discussed about Docker, so we saw how it works, and we also built our own container, so that's done. And now moving on to Docker Compose, which basically helps us achieve what we want: run a database, Docker container, and application container. Of course, we can totally achieve that using just Docker. That should be no problem. But when we have multiple containers that depend on each other, well, it's more elegant to have them defined in the same place. So in the file, in the Docker Compose YAML file. So let's create that, docker compose.yaml. Again, the VS Code extension is going to help us here. So we have to specify the version. That's also always the first line of the file. If we take a look at here, compose file version 3. So we have multiple versions. You see here. So we are going to use 3.0, of course. So 3.0 means or requires at least this version of Docker, which I have installed. If it doesn't work, well, you can check out the Docker version, Docker engine version. By the way, I can see that in the Docker dashboard. If we open that, okay, Docker engine, and here it is, version 19. So we should be good to go for 3.0. Then we have to define the so-called services, and we also, remember, we work with networks and volumes. We are gonna work with those. So our first service would be the database. So we have the application, the database. The application depends on the database, so let's define the database first. So we are going to call it DB. That's an arbitrary name. You can call it whatever you want. So let's call it DB. It's going to have an image, of course. The image will be Postgres, of course. So Postgres. Then what else? By the way, pretty much all containers list on the Docker Hub how to run it with Docker Compose. So also, if you see here, so they list the image, the restart policy. So if we copy that, basically that tells Docker what to do when the container exits, when the container stops. Maybe we stop it, maybe it crashed for some reason. And in this case, we want to always restart it. So if it goes down, it gets restarted. Now, there is one instance in which it doesn't get restarted if we manually stop it. However, if we restart the Docker engine, then the container will be restarted automatically. Instead of always, there is always also the unless stopped policy, and the only difference between this and always is that it doesn't the container will not restart after the Docker engine starts again. But let's go with always. Okay. What else? Well, they also list the environment. So basically, this is a way to provide environmental variables to the container. And of course, Postgres uses some well-known environmental variables. Excuse me. So we have to give it a password. Of course, it always also takes, we can configure the user, also the database, and of course some other parameters. You can see them here, or also in the Postgres documentation itself. Now we can totally list the values here, but a more nicer approach is to define them in env files. So you can see here I have this .env file, which until now has been used by the application. So if we look in the JavaScript code, I have this required.env.config. So basically that just loads whatever is defined in the env file before running the application. So if we comment that out, because we will no longer need that, also here, yes. So we no longer import this file. We let Docker Compose automatically import it and then feed the environmental variables or set them for each container. So in our case, we want to take the values from the environmental variables that we already set. So Docker Compose already sets those values in the environment before actually starting the container. So let's just pick those, db password. Now maybe we don't have this, maybe this is missing, maybe it's like that. We can also define a default value, and we do it like this, using those two characters. By the way, it should also work with this. The difference is if we do it like this, it uses the default value even if the db password is empty. So it is defined but with an empty string, as opposed to just this, which sets or uses the default value only if the variable is not defined at all, so it doesn't exist. So it's like this. But of course we are going to use this one, and the default value would be Postgres maybe, and here we go for something else. Maybe we generate it or something like that. Let's save that. Of course, then also the user, let's pick it from here. So db username, defaulted to Postgres, of course. DB database. Okay, so that should be all for the environment. That should be all for Postgres to run. Now we also want to define the networks and volumes. Maybe we start with the volume. Now we have the database, and database, of course, a database stores data on the disk. It stores the data in some files, and well, the issue is that if that data is stored in the container itself, as soon as we stop the container or maybe kill the container or remove it, then we lost the data, and that's not ideal at all. And of course we want to treat containers as cattle, if you ever heard about that analogy. So pets versus cattle, meaning that we should be able to get rid of the container without breaking anything, without losing data and so on. And we can use volumes to achieve that. If we type volumes, of course we have volumes, and we have to give it a name. Now let's comment that out for a second, and we have the volume here. So volumes, and let's call it maybe data, maybe not like this, like this. Yeah, so right now we define the volume called data. It doesn't need any configuration, doesn't need any stuff. Of course, we can configure the driver, I think, and some other stuff. You can find that in the documentation if you need to, but in most cases you will not need anything. So we define the volume here, and then going back to the volumes in the database, we tell it to, hey, use this volume and map it to, or in other words, store the database data in that volume, and that volume will actually be stored on the host machine, so on my computer on Windows. And if we look for volumes, so we have to map a certain file, of course, to our volume. Where is that? Is this it? Let's see. Yeah, I think that's it. So this is how we tell it's not DB, it's data, of course. This is how we tell Docker to map those files or files in that directory on our volume, in our volume. Okay, and then to the networks. So let's define first the network. So remember, we are going to have multiple containers, 2 containers, and we want them to be able to communicate with them. Now, they can do that by default, of course. However, we would like to have a bit more control over that, and for that we can define a network, just like we define a volume. We define the quote network. Again, it has multiple fields that can be set, multiple configurations. One of them being, again, the driver. For example, the driver is by default bridge, but we don't have to set it, we need bridge. Okay, and we tell it, hey, use the network I just defined. So quote. Okay, that should be all for the database. Now moving on to our application, let's call it app. By the way, this name is relevant just for Docker Compose. We're going to see that in a few minutes. So let's define the how Docker Compose should run our application. Now we can, here we have to define which image to use. Now remember, since we gave our image a name, it was called YouTube. So YouTube, we can give it or provide a name like that. If we wouldn't have named it, we could use build with the context, and basically that tells Docker Compose where to look for Docker files. So for a Docker file, and in our case we want to look in the current directory. So you see they're in the same directory. Maybe let's run it like that. So we have 2 different examples. Now we have the image set up. What else? Restart always, of course. Let's copy that. Also some environment, in the environment setting. Well, our application uses different variables, of course, and they use the same name as in here. So that, well, actually it's like that. Okay, we have that. Also the DB host, so meaning where to find the database. Now you see here, so most of the times you will see something like this, so localhost, and it's totally fine. However, since we use Docker Compose, we can use, since we use Docker Compose and user-defined networks, we can use the name defined in here as the host. So we can use DB, this DB. Okay, so we have that DB host, and that should be by default localhost. That's the right value most of the times, at least when during development. Okay, we have that. Not sure if we need anything else. There is one more thing that we need. Well, our application kind of needs the database, and just because we define them in this order doesn't mean they will start in this order. So we can define dependencies. We can say, okay, I want this application to run only when this container is up and running, and we can use depends on, again, DB. So that DB. It's an array, so it can depend on multiple containers. Okay, and that should be it. If we save the files and go back to our terminal, well, now we no longer use Docker, we use Docker Compose, of course, and we have Docker Compose up. So up is not a Docker command, it's just specific to Docker Compose. And we can also tell it to build. By default, it will build it if it hasn't already built it. But if it has built it, it's not going to build it again. Meaning that if we change something in the application, it's not going to copy the new changes in the container. So we should build it most of the times. Now if we run it, you see it created the network, it created the volume. Okay, looks good so far. So it's right now it's creating the application image because we need it. If we give it a second, don't worry about that, it's just a warning. And we can see it's creating the database. And well, we have a small issue. Why? You might also, you see here the restart policy, it continuously restarts the application, so it creates the container again. And of course the issue here is that we didn't specify the network. Let's copy that, set it in here, run Docker Compose up again. Now it built it much faster and it's already up and running. And it's listening, and if we go to our local host, well, it's not gonna run because, well, we forgot to expose the ports. And of course, since one of the benefits of using Docker Compose is that it's a more expressive way to list what our application needs, or what the containers do, we can use the file again to define the ports. And again, so this is Postgres, so we expose the Postgres port, of course, and for the application we expose the application port, which is 3000 in our case. Now if we run it again, so let's stop it. Okay, let's give it a second. So at this point it attempts to gracefully stop the container, meaning that it will send a certain signal to each process in the container, telling it, hey, you have a certain time to stop whatever you are doing, maybe do some cleanup, maybe save some data and stuff like that. Okay, and now if you run it again, this time we are going to provide one more parameter, so -d, so that's daemon, meaning that we no longer want to take up our terminal, we just want it to run in the background. If we issue the command, well, it gives us the control back. Okay, Now we can docker compose, we can issue docker compose ps, which should print the two containers. Okay, now if we go to our browser and refresh the page, well, something didn't work. And the issue here is that we need to, well, remember, we just created the database, so it has nothing in it. It has no quotes, no users, nothing. We want to migrate some, well, first of all, we don't have the tables themselves. We want to migrate the schema and also seed some data. So we'll provide some quotes that we can see in the application after. And for that, we can, well, there are multiple ways to do that. So the migrations are already defined in the application. You see them here. We just need a way to run the CLI. So CLI is the ORM that the application uses to talk to the database. So we need to use the CLI in order to run the migrations. And for that, the simplest way would be to leverage the already existing container. So the container that already has the application, including the migrations and seeders. So yeah, we can try to access that container somehow and execute some commands inside it. And for that, we have docker compose exec -it. I think we don't even have to provide it. Maybe let's do it like that. Let's try without docker compose. So docker ps, let's find out the ID of the app container, and then docker exec -it not dash, so the ID of the container, and then what to execute in the container. We want a shell, and here it is. We are inside the container. Print working directory. We are inside the application folder, so we even can do this. We see the files of the application, and here we can execute. Before we continue, let's see what happens if we do that without the it command, without the it parameter. You see, it's not very helpful because it basically doesn't allow us to do anything. However, if we provide -i, it is going to allow us to provide some input. Basically what it does, it maps our input to the container standard input. You see, we can now run commands. We can do that, maybe not like that. However, if we run it with t, so that's gonna create a pseudo terminal for us. So it will create a way to properly communicate through the terminal with the container. Okay. By the way, this didn't work because even though we mapped the input to the standard in, the output isn't mapped. So we cannot see what happens actually. Now, going back into the container, we want to run the migrations. We can use npx for that. So npx CLI db migrate, and it run the migrations. So this video is not about the CLI nor about npx, so let's not waste any time on that, even though they are interesting, of course. Seed.all, and now if we go back into our browser and refresh the page, we have a quote. So yeah, that was it. If we try using docker compose, well, actually, let's see. Docker compose offers some additional commands. One of the most useful ones being logs. So docker compose logs and then the name of the container. Maybe let's see why the application crashed previously. Yeah, we can see here that it didn't manage to find the quotes table. So there is that, and let's try to execute or to access the shell in the container using Docker Compose. And if we try without the IT flags, because there are two, we should also be able to use the name. So docker exec app, not really. Maybe sh. Yeah, and we have it. So we also had to provide the program that we want to execute. So you see, in case of Docker Compose, we no longer need the IT flags because it already does that for us. Because in the end, Docker Compose, that's what Docker Compose does. It abstracts certain features of Docker and makes them easier to use. And well, that should be all. That was the bonus issue I was referring to, by the way, the seeders and running the command inside the container. Of course, we can stop the application, docker compose stop. So now it's stopping the containers. Remember, in the beginning of the video, we talked about docker create and docker start. Well, this is one of the few places in which we actually would use start as a separate command. That would be to start the containers again. And of course, if we want to get rid of them entirely, we can say docker compose down, and also we want to get rid of everything else, also of the networks and volumes. We are done with this project. We can also provide the -v, so that's going to delete also the volumes. And right now it's getting rid of everything, so stopping the containers. Then it should remove the containers, the network, and the volume, and that should be it. So I hope you found this useful. I know it's a long video, but well, certain topics that we discussed can be a bit hard to understand, or well, it's much easier for us to use Docker if we understand certain things, and that's what I tried to provide with this video. So thank you for watching me. Thank you for following along. If you reach the end, well, you're gonna go far. You're gonna go very far. So thank you. I hope you found this useful and interesting, and see you soon. Bye.